In the following video, we are going to examine graphing quadratic equations and identifying all of the parts from the graph. And this can assist us when we start to develop our understanding of how to solve a quadratic equation by graphing. So we know from the previous lesson that when you graph a quadratic function, you're going to get a parabola, and that is the U-shaped graph that we've done previously. So on this graph provided, I'm going to sketch a parabola, and in that parabola we are going to label and define all of the parts. So it's any parabola, doesn't matter what I have. So here is my parabola. I want to define the axis of symmetry and label it. So remember, the axis of symmetry cuts the image in half. So the way that we would define it is we would say that the axis of symmetry, which we've used before, AOS, is a vertical line through the vertex. And remember, that tells you that a parabola is symmetrical. It's going to cut straight through the middle, which happens to go through the vertex, which means the left side is going to be an equal distance away from the line of symmetry as the right side. So if I were to draw it, this one looks like it goes straight through the middle there. And so this is my axis of symmetry. Next, I'm asked to define and label the vertex. So the vertex we've learned from before is either the maximum or minimum point, the highest or lowest point on the graph. And so my vertex here is right there. And so this is my vertex. The axis of symmetry goes through the vertex. It's the lowest point on the graph. And next is the new concept, the idea of zeros. Now, zeros of a graph, of a quadratic, are the X-intercepts of the parabola. And that means it is the locations where it crosses the x-axis. And so if I want to label my zeros, I see I have two zeros. Here's one x-intercept, and here's the other x-intercept. So these are my zeros. Now the zeros are the important part of a graph because they actually tell you the solutions to the quadratic equation, and that's what we're going into in this lesson, is how to solve a quadratic equation by graphing, which means how to find the zeros of the quadratic equation. So in the following, define a quadratic equation and give an example of it. So let's move these two down, and we can define a quadratic equation, give an example. So an example of a quadratic equation we can use is, let's say it's x squared minus 3x plus 6. So quadratic equation is going to be a parabola with a quadratic, a linear, and a constant term. Next, let's define roots. Now the roots of a quadratic equation are the solutions. So roots for a quadratic equation are the solutions to a quadratic. Which leads us to this last part. What is the relationship between roots and zeros, x-intercepts? So here we go. We can set this up like an equation. We've learned that roots represent our solutions. Zeros represent our solutions, and zeros are your x-intercepts. And so x-intercepts represent our solutions. So they're all the same thing. If I want the solution to the equation, I'm asking for the roots, which are the zeros, which are the x-intercepts. So it's really solution to a quadratic roots, zeros, and x-intercepts are four separate terms and have the same meaning. We just use them in different contexts. When I ask for the roots, I want the solutions. When I ask for the zeros, what you're looking for is looking for the place on the graph when the equation equals 0. And x-intercepts, you're looking for where it crosses the x-axis. All four words, solutions, roots, zeros, x-intercepts. Here we see the three words, roots, zeros, x-intercepts. All of them mean the same thing. It's just different context for each term. When you're looking at the graph, you're looking for the x-intercepts. When you're looking at the equation, we're looking for the zeros. I just give you quadratic, I'm looking for the solution. You're trying to identify the roots, which means set it equal to 0, find the solutions. So be aware that all four terms, solution, roots, zeros, and x-intercepts, are interchangeable when dealing with quadratics.